going to start with a special case study guaranteed to leave you completely stunned. Please welcome to the stage a lovely 2024 GITEX welcome from New Zealand, double Academy Award winner for animation for King Kong and Avatar, and creator of Baby X, co-founder and former scientific officer of Soul Machines. Please put a rather excellent trade show welcome round of applause together for Dr. Mark Sagar.
Thank you, everybody, and good afternoon. So today I'm actually going to talk to you about Baby X, but I want you to think of it in the context of character technology, interactive multimodal AI, and where this is going for the future of human-machine interaction. Now, the magic of animation is that it creates the illusion of life. It's like we think that an artificial character is thinking and feeling and has emotion. This is the very first animated movie. It was done over 120 years ago, but it's very appropriate because it's got faces in it and it's about the relationship between two people. We understand the motivations of a character by reading the expression and body language. The character has a physicality and it's connected with the world, and the character appears sentient. To authentically animate such a character, the artist, like a method actor, has to imagine what it is like to be that character, what thoughts and feelings it has. What if we could actually simulate this illusion of life from the inside out to create truly autonomous characters which have their own cognition, agency, motivation and emotion from the subjective perspective of the character itself? We'd need to simulate not only the character's body, but also the character's mind. It may well be that the condition of having a mind requires having a body. There's a theory for this, which is embodied cognition. So if there's one part of the body that really represents the connection between mind and body, that's the face. So to simulate the face, one of the most important things is simulating expression. This is the music of the face. So I worked on technology which allows you to break down facial expression and put it on different character faces. And so this has been used for lots of different films to make all kinds of different types of faces. I've also looked at how to biomechanically simulate a face so that you can basically create a mathematical model of the face. What you're looking at here is a physics-based simulation. The only thing which is not part of the model are the blood vessels. And so once we build up all the complex layers of facial anatomy, we can then activate the model and start generating expressions. So this is basically a generative model of facial expression. So like generative AI generates from statistics, this is generating from physics. Now, the face doesn't move at random. The face is the mirror of the brain. Everything that happens on your face is as a result of something happening internally. So this means that to make an autonomous character, we actually have to simulate a brain. This is no easy task, and it's enormous, but what I was thinking with this is it's not doing the human brain project. It's building effectively a toy model of a brain, but making sure that you've got all the right components connected so that you can basically close the loop and actually have something that you can interact with. So it's like a large functioning sketch. To do this, we actually have to simulate many different functions of the brain, like, for example, vision, hearing, decision-making, emotion, and so forth. And so we need to build a model which puts all these together. Now, to try to make sense of something as complex as the brain, we need to look at organizing principles. The brain is actually part of the nervous system, which is part of the body, which is in an environment, and there's lots of feedback loops going on. So, for example, our sensory systems don't not only pick up what we see, but they also pick up how our body feels. So in order to put all this together, we developed a a language called brain language, which allows us to interconnect lots of different types of neural networks. Now you'll see here, we can actually see the activity of a single neuron, and this neuron, and you can create a virtual connectome. So this neuron is connected to lots of other components in a network. So, for example, we have deep networks, different neural circuits, depending on what is actually happening and what type the model is. So, and we end up forming a virtual connectome. Now, what sort of body do we put this in? So what's the right embodiment to start with a brain model? So it turns out that babies exemplify what is needed for an intelligent machine to learn autonomously. Babies have experienced the world as profoundly multimodal, and babies don't start off smart. Like large language models at the moment are trained on the internet. They already have the knowledge and its statistical compression, but how we learn is through exploring the world and experimenting. We physically interact all the time and we explore and play. Now, play is such a key part of making intelligence open-ended and inventive that it's one thing which is probably what's missing from current AI at the moment. Babies are highly social as well. They learn as part of a system. And they learn language through social interaction. So what this does is it kind of grounds the meaning. So BabyX is an interactive simulation of an 18 to 24-month-old infant. It's autonomously animated in real time by a virtual nervous system. It's socially contingent, and it's developed with collaborators in cognitive science, computational linguistics, and developmental psychology. BabyX includes models of the motor system, cognitive system, sensory systems, and the behavioral state systems. And BabyX is tailored for multimodal interaction. So it works in real time, it interacts face-to-face, and there's a touch screen and it can interact with arbitrary content like anything on the internet. The compositional architecture supports emergent behavior. It's a simulation versus an animation. So this is a screen recording of BabyX.
Now, you can see me through the web camera. Oh yeah, baby. Hi.
So I don't know if there's audio.
Click on the keys.
I don't think we've got audio.
Okay, your turn. Yay, good job. Okay, so now you can see this from the side. So we can kind of see the screen that she can see. Now, every movement that she makes is driven by virtual muscles. So
Oops.
she is full 3D. So we can move around like this. Now, she can see me through the web camera. Hiya, baby. Hello. Okay, so I can click on the keys. Okay, your turn. Yay, good job.
So everything that's happening is she's
now,
deciding to do something. It's a simulation, so it's running live.
So we can kind of see the screen that she can see. Now, every movement that she makes is driven by virtual muscles. So here we see her muscular system.
So you can see the muscular system which
And
is
the
driving her
muscles,
movement.
in turn, are driven by her digital brain. This shows the different regions of the virtual brain activating, which are driving what she's doing depending on the
So
task.
different brain regions are driving
Searching
different
for something
aspects of
or
the
moving
behaviour.
around or listening. Now, the brain and all of her behaviour is actually modulated by her behavioural state system. And this internally regulates what she does, then also regulates a virtual heart.
So BabyX is driven by a cognitive architecture. Now the design of the cognitive system is called a cognitive architecture, which is a hypothesis about how the mind works. And it's a model of the component structures that are needed to work together to yield intelligent behaviour in a diversity of situations. So if we're ever going to generate artificial general intelligence, we need to take a very comprehensive approach, very holistic approach. So Baby X's cognitive architecture is designed to recognise and create meaning out of all the things going on in a typical interaction, to plan, to set goals, to experiment and play, and to link all of these with language. So, unlike a large language model, which is learning from a huge database, Baby X is learning language through interaction, through being taught, and grounding the meaning of what is being explained with real experience. Baby X is learning through curiosity, through observing things, and through social interaction. So we're trying to build a model which is taught in the same way that we teach children. So how do we validate such a model? So we've been doing a developmental psychology study where we have parents or caregivers interacting with Baby X in the way that they interact with real children. And it means that we can do world-first experiments because we can actually change the behaviour of a baby, which you can't do in real life. And it allows us to study one of the most important things, which is how we raise our children, because how we interact with our children sets up their functioning for the rest of their life. And it's interesting to think about this as a paradigm for the interactive teaching and socialisation of AI. So this is an example experimental setup. So on the right, you can see a touch screen, and we're doing an experiment with about 80 participants. They've never seen Baby X before, and they're just told to go and interact and play games. So I'll hit play, and you'll see the difference in behaviour between the different parents. And so the Baby X has to learn in both of those in any situation.
The tall tower.
Tower. Two.
Uh-oh. Can you knock it down? Oh, there we go. Oh, no. Can you knock any more?
Yeah, it's down.
It's down. I still see some standing. Oh, there you go. We've got a farm with lots of animals. This one is a...
What is that?
Is that a chicken? What does a chicken say?
Chicken move like me.
Chicken move like you?
Chicken say cluck, cluck.
Good job. That's
Chicken
right.
happy like me.
Are you happy too? I'm so glad to hear.
So what drives Baby X? So a fundamental and deep question in autonomous mental development is, how is an autonomous system motivated? So Baby X is motivated both by extrinsic motivations such as rewards and punishments, which is like reinforcement learning, but critical to autonomous self-learning systems, Baby X has intrinsic curiosity and strives for social connection. So what you'll see next is Baby X basically exploring things that she's uncertain of. So curiosity is about minimizing surprise. It's about aligning our internal models with what we sense.
Ladybug red?
Yes, that's red.
So she's asking questions about what she doesn't know.
Is this butterfly?
Yes, it's a butterfly. Good. Yeah.
EA.
What's this?
Is this bee?
Yes, it's a bee. Good.
So a very strong influence on motivation is emotion. So emotion is where the body and the mind really come together. In fact, many cognitive scientists believe that cognition and emotion are inseparable. So emotion coordinates the brain and the body, and it's a key motivational factor and incredibly important in decision making. So, and it's actually how we empathize as well. So it's a fundamental part of the illusion of life. So the way we model emotion is based on effective neuroscience. So we combine a lot of the leading models in that area to drive the emotional systems of Baby X. And this next clip will actually show how emotion is involved in, so there's emotional association which is learned, and then this affects decision making.
Do you like the octopus?
Yes, it's good.
Do you like the crab?
No, it's scary.
Can you put the crab next to the starfish?
No, it's scary.
Can you put the octopus next to the starfish? Good job.
So it doesn't have to be a specific stimulus. It can actually be the dynamic quality of something. So how is it that we come to like and dislike different types of things? So here we're going to show Baby X is going to watch a classic experiment video with abstract shapes in it. And she's going to have an emotional reaction towards some of these objects.
Okay, I watch. Not once.
So she doesn't like the aggressive motion that's happening from one of the objects. And so she's learning to associate that she really doesn't like that big triangle. So memory is another critical piece that you have to add to a cognitive model. So Baby X has multiple types of memory. There's sensory memory, which is like a buffer. There's short-term memory, which is like a notepad. There's working memory, which is how we manipulate the contents of that notepad. Long-term is like an archive, but the most personal form of memory is episodic memory. It's based on our direct experience, and it's fascinating to think what a digital character might subjectively experience. So William James famously wrote, "Where is it, this present? It is melted in our grasp, fled ere we could touch it, gone in the instant of becoming," to try to capture what is going on in a moment. So what is it like to be Baby X? This is an attempt to sort of visualize the sensorium of all the different types of things going on in Baby X at any one moment. So you'll see everything from proprioception to hearing to planning to emotion, and even Baby X's inner theatre in a way. So I'll run a video and kind of explain what's going on.
What is?
This is an octopus.
So on the right, you'll see sort of Baby X's mind's eye view.
Me move. Yeah, an octopus.
And it's triggering memories.
It goes here.
Move.
Octopus goes here.
You see, every time I'm speaking, suddenly her focus will go
Where
off
does the
screen.
octopus go?
Me not know that.
Here. Good job. Nice.
So on
Where
this
is
one
the
here, you'll
starfish?
see the different brain regions lighting up. So if she's going to move something, her motor
Good.
region will light up.
Can
And
you
you'll
move
see
the
how the
turtle?
different areas come in and out of attention. So if you think about our experience of the world, we're constantly focusing on different things depending on what's happening. It might be a memory, it could be something happening in front of
don't
us, a
know.
loud noise.
It's a crab.
But Baby X is trying to make sense out of all these things
Yeah.
happening, whether they're internal or external. Now, we don't just make babies, and we basically also created adult faces. So these are simulated faces which are driven by an internal nervous system. And these models mean that you can start exploring very interesting things, such as effectively what we're going to look at here is models of empathy. Now, a computer can't be empathetic, but it can behave in an empathetic way on the surface. So I'll just play this, and you'll see that every reaction that you're going to see now is being completely automatically generated.
Hey there, can you hear me? Well, I'm going to tell you about my week. Actually, the last couple of days, it's been very challenging for me. It's been very difficult. I've been really struggling with a lot of very sad things, and And then, the last day was actually quite irritating, as everything was just not going my way. It was really, really frustrating. I didn't know what to do. But I'm hoping that tomorrow is going to be a great day, and I'm really looking forward to it.
Okay, so this is of course no match for real empathy from another human. A computer can never experience human suffering, for example, but there's communicative value in acknowledging the user's emotion. So in 2016, together with co-founders David Bullivant and Greg Cross, we spun the technology out into a company called Soul Machines with the goal of humanising AI. Now, Soul Machines is dedicated to the positive use of AI and is focused on the creation of digital humans that can assist you, that you can practice with for self-improvement. You can also integrate the large language model, for example, of your choice and create your own application. So I'll show an example of a few different assistants that you can build.
Hi, I'm Mia, your digital assistant to help you navigate the corporate world with confidence. Hello there, traveler. I'm Vespa, your cultural and travel AI assistant.
Hi, I'm Alex, an English language AI assistant. As an AI assistant, I provide personalized one-on-one feedback. You can learn at your own pace with no time constraints and in a pressure-free environment. Tell me what scenario you want to practice and we can role play, like small talk at an event, a business meeting, or talking to a customer. If you don't know, then just ask me to suggest one. You can also create your own Soul Machines AI assistant using Soul Machines Studio. Quickly launch one of our ready-to-go templates or easily create a fully customized assistant that's totally unique. An AI assistant from Soul Machines can help engage your audience and monetize your content. So come talk to me now, or create your own AI assistant at soulmachines.com.
So this is an example of some of the faces that you can build on the Soul Machines Studio. So you can make all kinds of different sort of models. You can change the hair, clothes, whatever, and they're extremely expressive. Now, we've also used digital humans in health applications. This is an example of a model that we built for the World Health Organization during COVID. And since that time, we've expanded the work to cover multiple languages. We've also done lots of research on the use of digital humans in health and well-being, including studies on loneliness, mental health, and so forth. And we've published lots of papers over the years, and they're really showing the effectiveness of these models in actually making people feel better. So where is this all leading us? We've seen that we need to holistically coordinate a lot of factors in order to make a computer be able to interact with you naturally face to face. As AI gets more powerful and ubiquitous, we need to think about it, how we can best interact with it that brings about a desirable future. It also opens up the possibility to create digital companions, because research has shown that these robots and embodied conversational agents can help reduce loneliness, which is one of the leading causes of death in the United States. Addressing loneliness in older adults will enhance individual well-being and reduce healthcare costs, benefiting society as a whole. But you don't want to make it something that replaces real people. This is for the case where there is no real people around, there are no real people around to look after people. So you can make a proactive, empathetic, emotional regulation support, mindset coaching, and motivation to promote well-being, health, and interdependence. Now, if we can also create animation autonomously, it means that for entertainment and gaming, you can create truly autonomous characters. What happens next is co-created. Imagine if you're sitting next to King Kong. Whatever you do may change what happens next, and vice versa. So we're co-creating an experience, and you've got the excitement of effectively a live event. But it also can change the way that we interact with technology. Human cooperation is the most powerful force in history, but human cooperation with intelligent machines will define the next era. So how do we best cooperate? We have shared intentionality, and we need to understand shared context. This is the alignment problem. We need to have mutual responsiveness. If somebody's doing something, we need to adjust our actions accordingly, and we need to support each other, help each other out if we're struggling. Now, if we think about this sort of situation in a self-driving car, we need to know these elements. Like, for example, we need to know where the car is focused. Has it seen that pedestrian? Is it aware of those things going on? Is it going where we want it to go? Do we know whether it's getting an overload of information? Does it have a situational awareness? So the types of things that we take for granted in other people are things that we have to have in machines. Now, communication can be communicated so this information can be communicated in multiple ways. But the more anthropomorphized it is, the more intuitive to understand. We can understand something at a glance, and it may be not what it looks like, it might be the behavior of it. But when we're dealing with interactive AI, we need something to interact with. There has to be some form of embodiment. So the embodiment is the nexus for interaction with AI. We need to really think about what it is that we're going to interact with. If we revisit the plan of the nervous system and we replace these components with the elements of cooperation, it turns out they're almost the same. So the elements that are required to simulate the illusion of life are the same as those needed with cooperation with intelligent machines. And I'll finish there, and thank you very much. And I can take some questions.